If f of x equals 2x squared plus 7x minus 9, find the equation of the line tangent at x equals negative 2. Well, the equation of a tangent line, of any line, that is found by using this formula here, which requires the use of a point that exists on the line and a slope of the line. The slope we need to get through some sort of means to calculate a tangent, so the value of a derivative. The point that exists on the line we can just use. If x equals negative 2, then that means f of negative 2 is 2 times negative 2 squared plus 7 times negative 2 minus 9, which would be, let's see, that's 4 times 2 is 8, minus 14 minus 9. So 8 minus 9 is negative 1. This looks like negative 15. So that is the point that exists on the line. So negative 2, negative 15. So there's an x and a y. Now what I need is the slope of the tangent line at that particular point. And what I can do is take the slopes of secant lines. On the slope of a secant line, what you do is you take some point on the graph. So 2x squared plus 7x minus 9 minus the point of interest, so minus negative 15, the y value that is. So this is y2 minus y1 that I'm setting up, over x2, which is just going to be some random x value, minus negative 2. So 2x squared plus 7x, and this would change to a plus 15, so negative 9 plus 15 would be plus 6, and this is plus 2 in the denominator. Now, if I try and plug in negative 2, I'm going to have trouble there. I think that's going to give me a 0 in the numerator. Let's try it out. So negative 2, well, yeah, negative 2 squared is 4. Let me just do the easy way. So then times 2. Plus 7 times negative 2, so that's actually minus 14, then plus 6. Yeah, so when I plug in negative 2, I get 0 in the numerator and 0 in the denominator. But if you'll recall from limits, that means that we have a way of actually factoring in order to get rid of that. We might be able to still evaluate this if we get rid of that factor. So let's see. 2x and x, and this could be 3 and 2, those multiply to 6. And it looks like if they're both positive, we are in luck, because that would be 3x plus 4x, which is 7x. And x plus 2 cancels out, leaving me just 2x plus 3. So the slope of any of the tangent line at this particular point can now be found by evaluating this at negative 2. So m of negative 2 is 2 times negative 2 plus 3. So that's negative 4 plus 3, which is negative 1. So the equation of my tangent line, y minus negative 15 equals negative x minus negative 2, or y plus 15 equals negative x plus 2, and y equals negative x, so minus 2 plus, whoops, better be careful there, minus another 15, so y equals negative x minus 17. And there's the equation of the line tangent to the curve. Certainly we're going to come up with means of doing this sort of thing much easier in the near future, but for now that's really all we have.